So the next question is, for how long does a current of 0.3 amperes need to pass through a solution of copper sulfate to deposit 0.8 grams of copper? So let's make this very snappy, since we have gotten idea on how to go about calculating questions. So what we need to do first is to know the unit, or rather the oxidation state of copper. And what is that oxidation state of copper? Look at it from the electrochemical series. Copper is +2, so that should be stuck into our memory. So copper is +2. So let's proceed. Now the next thing we ought to do is to bring out our parameters. We have been given 0.3 amperes. We've been given 0.8 grams of copper. So this is an experiment that has been done. This time around we are not asked to calculate the mass of copper that will be deposited. Already it has been done. It has been seen that 0.8 grams of copper was deposited, and the quantity of current that went was 0.3 amperes. So the question now is, we are asked to calculate the time it took for this 0.8 grams of copper to be deposited. So this is a case of time now, but the previous question, the example 2 we just saw, is for us to calculate mass. So this time around we are dealing with copper, Cu, and we know that Cu is having 2+. So let's leave it at that. Now we have been given the mass. The mass of copper that was deposited at the cathode was 0.8 grams, and we are told that the current is 0.3 amperes, as we can see, 0.3 amperes, and we are told to calculate the time it took for this 0.8 grams of copper to be deposited. We have to calculate the time. So what do we need to do? What you need to do next is to say we have to write out the ionic equation. So for copper to be deposited, it means copper 2+ we have to gain 2 electrons, so that the 2 electrons will cancel out the 2+, and copper is now deposited as a solid matter on the cathode. So this is actually what should happen. So having written our equation, the ionic equation, the next we will now have to say is, from this ionic equation now, it is clear that 2 Faradays, or 2 moles of electrons, since electron is equivalent to Faraday, 2 moles of electron deposited 1 mole of copper, or we may say 2 Faradays deposited 1 mole of copper. So if that is the case, we now have to say, let us always remember that we are calculating for time. We are looking for time, and to look for time, we can make use of the formula Q equals IT. So let's have that at the back of our mind. But let's proceed first to know the quantity of electricity that has been passed, or that was produced. So from what we have here, from the equation, 2 Faradays gave us 1 mole of copper. That is to say, 2 Faraday is giving us 1 mole. 1 mole of copper. That is 2 times 96,500 is giving us 1 mole of copper. And 1 mole of copper from the equation is 64. That's the relative atomic mass is 64. So we can say 64 grams. So can you see that? So from this equation, 2 times 96,500 coulombs of Faraday, or electricity, has given us 64 grams of copper. So what is 2 times 96,500? So 2 times 96,500 is equal to 193,000. So it means that 193,000 coulombs of electricity from the equation has produced 64 grams of copper. That is what it means. So what we need to ask ourselves then is, what quantity of electricity then should have produced this 0.8 grams, because this time around we were told that the mass of the copper has been produced. Ordinarily, what we should have done here is to say, let's say, since 193,000 coulombs of electricity gives 64 grams of copper. Ordinarily, what we should have said, like in the previous example, is let's say 21,500 500 coulombs of electricity will give X, and then we will now go ahead looking for the mass of the copper that will be produced. But this time, the mass of copper has been produced. We are told that they've gotten already the mass of copper produced. So what we need to know is, what is the quantity of electricity that gave us that mass of copper, this 0.8 grams of copper produced? Because we don't know the quantity of electricity that did that. So that is why we have to find that out. So if from the equation now we have seen that 193,000 coulombs of electricity will give us 64 grams of copper. So what we will need to ask ourselves is, what is the quantity of electricity that must have produced 0.8 grams of copper? So what quantity of electricity must have produced 0.8 grams of copper? That is what we need to do. So we have to go ahead, cross multiply and solve. So when we cross multiplying, we have 64x is equal to 0.8 times 193,000. So our calculator is already there, so we just multiply by 0.8 by 0.8. So once we multiply 193,000 times 0.8, that gives us 154,400. So we have 154400, 154,400. So to calculate for X, which is the quantity of electricity that led to the production of 0.8 grams of copper, then it means our X will be 154400 divide 64. That will give us 2412.5. So it means that 2412.5 coulombs of electricity produce that. So we can see that 2412.5 coulombs of electricity gave us that 0.8 grams of copper. That is just what it simply means. So to get our time, that is the time for which this quantity of electricity passed through, is now the next thing we ought to do. So how do we go about calculating the time for which this quantity of electricity passed through? So to get our time is to say Q is equal to IT, and our Q is just what we have solved for. So X is equals Q, which is the quantity of electricity that has passed through, 2412.5 coulombs. 2412.5 coulombs. So to get our Q, our T, is to say 2412.5 coulombs is equal to IT. Our I is 0.3 times T. So this gives us, making T subject to the formula, 2412.5 is equal to 0.3 T. So to get our T is to divide both sides by 0.3. I beg your pardon. We have to divide both sides by 0.3 to make T subject of the formula and let it stand alone. So we are dividing both sides by 0.3. So 0.3 can take care of 0.3. That has gone. So we have our T as 2412.5 divides 0.3. So our T will be, from there we have, from our calculator there, we have 2412.5 divide 0.3. So we have 8041.7 seconds. If we wish to leave it as a whole number, then we can say 8042 seconds. So this is actually how long it took to get that done. So it's as simple as that. If we want to take it to minutes, we can still go ahead, divide by 60. That gives you your time in minutes. So this is actually how long it took for that mass of copper to be deposited. That is 0.8 grams of copper to be deposited. It took 8,041.7 seconds, or to a whole number 8,042 seconds for that something to be done. So this is actually how to calculate questions that involves masses and time.